Okay, imagine this. Right now, as you're watching this video, invisible waves are passing through your body, through your bones, your organs, your brain. These aren't sound waves or light waves. There's something far stranger. They're ripples in the very fabric of space and time itself. And here's the wild part. You're not just being hit by these waves. In a very real sense, you are made of them. I know that sounds completely insane, but stick with me. Because once you understand what gravity waves actually are, you'll never look at yourself or the universe the same way again. So, let's start with the basics. What are gravity waves? Well, first, we need to talk about gravity itself. And trust me, it's not what you learned in high school. For centuries, people thought gravity was just a force, like magnets pulling on metal. Isaac Newton described it that way, and honestly, his math worked pretty well. But then Einstein showed up in 1915 with his general theory of relativity, and basically said, nope, gravity isn't a force at all. Instead, Einstein showed us that space and time aren't separate things. They're woven together into what physicists call spacetime. It's like a fabric, a cosmic trampoline, if you will. And massive objects, like stars and planets, don't pull on other objects. They bend this fabric. They create dips and curves in spacetime itself. Think about it like this. Imagine you've got a trampoline stretched out flat. Now put a bowling ball in the center. What happens? The trampoline sags, right? It curves around the ball. Now roll a marble across that trampoline. The marble doesn't go in a straight line anymore. It curves toward the bowling ball, not because the ball is pulling it, but because the marble is following the curve in the trampoline itself. That's gravity. You're not falling toward Earth because Earth is pulling you. You're falling because Earth has bent space-time around it, and you're just following that curve. Now here's where it gets mind-blowing. If space-time is a fabric, what happens when you disturb it? When something really massive accelerates or moves violently, it doesn't just bend space-time. It creates ripples, waves. Like throwing a rock into a pond, except the pond is literally the structure of reality itself. These are gravitational waves. And before you ask, yes, I said gravitational waves, not gravity waves. There's actually a difference. Gravity waves are something else entirely, involving fluid dynamics and atmospheric physics. What we're talking about here are gravitational waves, the ripples in spacetime predicted by Einstein. Einstein predicted these waves over a century ago, but he thought we'd never detect them. They're incredibly weak. When a gravitational wave passes through Earth, it stretches and squeezes space by an amount smaller than the width of an atomic nucleus. We're talking about measuring something that changes the distance between Earth and the Sun by less than the width of a human hair. But scientists are stubborn. In September 2015, the LIGO observatory, that's the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time. The source, two black holes, each about 30 times the mass of our Sun, spiraling into each other over 1 billion light-years away. When they finally merged, they released more energy in gravitational waves in a fraction of a second than all the stars in the observable universe combined, released as light. Let that sink in. The universe literally rang like a bell, and we heard it. If you want to dive even deeper into how gravitational waves connect us to the universe, check the description for our ebook. It goes into even more mind-blowing details about how these cosmic ripples shape everything around us, and how we're only just beginning to understand their role in our existence. Okay, so we've got these ripples in space-time traveling through the cosmos. Cool, but here's the part that's going to mess with your head. You're not separate from space-time. You exist within it. You're made of it. Every particle in your body, every atom, every electron, exists at a specific location in space-time. And space-time isn't some empty stage where matter just sits. It's dynamically connected to matter and energy. Matter tells space-time how to curve, and space-time tells matter how to move. It's a dance, a constant interaction. When gravitational waves pass through you, they're literally stretching and compressing the space-time that you're embedded in. Your body gets infinitesimally stretched in one direction and compressed in another. You don't feel it because it's so incredibly tiny, but it's happening, right now, as you watch this. But it goes deeper than that. Quantum mechanics tells us that particles aren't really little solid balls. They're more like waves of probability, excitations in quantum fields that permeate all of space. So in a very real sense, you're not a solid thing. You're a collection of ripples, of waves in various quantum fields, all existing within the fabric of spacetime, and gravitational waves. They're ripples in that very same fabric. So when we say you're made of gravitational waves, we're not being poetic, we're being literal. The distinction between you and the waves is a lot blurrier than you might think. Let me give you another way to think about this. Imagine the universe as an ocean. Not an ocean of water, but an ocean of spacetime. Everything that exists, stars, galaxies, black holes, you, me, we're all like different kinds of waves in this ocean. Some waves are big and slow, like the orbits of galaxies. Some are tiny and fast, like the vibrations of atoms. Gravitational waves are like the deep, powerful swells that travel across this ocean. They're created by the most violent events in the cosmos, colliding black holes, merging neutron stars, maybe even the birth of the universe itself. During the Big Bang, these waves carry information about the events that created them, and because they barely interact with matter, they travel through the universe almost unchanged. Light can get absorbed or scattered, but gravitational waves, they just keep going, carrying a pristine message from the most extreme corners of existence. When these waves wash over Earth, they wash over you. They pass through you. And for the briefest moment, the distance between the atoms in your left hand and the atoms in your right hand changes by an amount so tiny, it's almost meaningless. But here's what's not meaningless. You are connected, through spacetime itself, to every massive event that's ever happened in the universe. The merger of black holes a billion years ago sent out waves that might be passing through you right now. The spinning of neutron stars across the galaxy creates a constant background hum of gravitational waves that you're swimming in every single day. You're not separate from the cosmos. You're part of it. You're made of the same stuff, the same fabric. And this brings us to something truly exciting. Gravitational wave astronomy is brand new. Before 2015, we explored the universe using light, electromagnetic radiation, radio waves, visible light, X-rays, all different forms of light. But gravitational waves are completely different. They let us see, or rather feel, things that don't give off light at all, like black holes. Before gravitational waves, we could only detect black holes indirectly by watching how they affected nearby matter. Now, we can detect them directly. We can listen to them collide. Think about it this way. For all of human history, we've been exploring the universe like we're deaf, only able to see. Gravitational waves gave us hearing, and suddenly, the universe is filled with sounds we never knew existed. We're hearing the universe breathe. We're hearing its heartbeat, and every wave that passes through our detectors and through our bodies tells us a story about the nature of gravity, the behavior of matter under extreme conditions, and the history of the cosmos itself. So let's zoom out for a second. Why does any of this matter? Why should you care that gravitational waves exist, that they're passing through you, that you're in some sense made of them? Because it fundamentally changes how we understand our place in the universe. We're not observers standing outside looking in. We're participants. We're woven into the cosmic fabric. Every breath you take, every heartbeat, every thought happens within spacetime. And spacetime is constantly being shaped and reshaped by everything else in the universe. Those gravitational waves passing through you right now, they're evidence that the universe is alive, dynamic, constantly changing. Nothing is static. Nothing is separate. Everything is connected through the geometry of spacetime itself. And here's something even wilder to think about. Every time you move, every time you accelerate, you create your own tiny gravitational waves. They're unbelievably weak, far too weak to ever detect, but they exist. You are constantly sending out ripples in spacetime, announcing your presence to the cosmos. You're not just experiencing the universe, you're actively shaping it. So here we are. You clicked on this video thinking you'd learn about some weird physics thing called gravitational waves. And yeah, you did. But you also learned something deeper. You learned that the boundary between you and the rest of the universe is not as clear as you thought. You're not a separate thing existing in space. You're a pattern, a wave, a vibration in the fabric of space-time itself. And that fabric is shared by everything that exists. Those gravitational waves passing through you. They're not foreign, they're cousins. They're the same kind of disturbance in spacetime that you are, just on a much larger scale. You're made of the same stuff as colliding black holes and exploding stars. You're made of geometry. You're made of spacetime. You're made of gravitational waves. And once you really understand that, the universe stops being a cold, distant place and becomes something intimate, something you're a part of, not just in a metaphorical sense, but in the most literal, physical, scientific sense possible. The universe is a vast ocean of space-time, and you're not drowning in it. You're swimming. You're a wave in that ocean, connected to every other wave, shaped by every other wave, shaping every other wave in return. So the next time you look up at the stars, remember, you're not looking at something separate from yourself. You're looking at other waves in the same cosmic ocean. And somewhere out there, maybe a billion light years away, two black holes are colliding, sending out ripples that will eventually pass through your body, stretch you by less than an atom's width, and continue on into the infinite darkness beyond. And that's beautiful. That's profound. That's you. Thanks for watching. If this blew your mind even half as much as it blows mine every time I think about it, hit that like button and subscribe for more videos about the weird, wonderful, and deeply strange reality we all live in. And seriously, check out that ebook in the description if you want to go even deeper down this rabbit hole. Until next time, keep being the amazing cosmic wave that you are. See you in the next one.